Good morning, friends. So in the last lectures we studied a cone clutch. So that's why today I am taking third type of the clutch is the centrifugal clutch. We studied a single plate clutch, multi plate clutch. So as per the applications we can use when the space is available, more space is available, single plate clutch, and if the less limitations above the space, you can use multi-plate clutch, and if medium type of the means intermediate type space available, so then you can use cone clutch. So this is the third type of the clutch is the centrifugal clutch. So this centrifugal clutch, so some of the engines or some of the internal combustion engines, so that cannot be starting in the engaged positions. So before the no load, that is to be start, and after achieving the some of the speeds, so that can be engaged. So that purpose centrifugal type of the clutch can we use. So means the engaging of the clutch. So before taking the high speed up of the engines. So means or operating speed up of the engines before achieve operating speed up of the engine. So that can be engaging occurs because of the centrifugal clutch. So that's why today we'll see centrifugal clutch. So in centrifugal clutch, here three parts are important. One is the drum, is four parts. That is the drum, in which all parts means that spiders, brake shoes, and with along with springs, that is to be enclosed. So suppose this is a drum. So in this drum, brake liner, so this is a step of the brake liner. And here's This is spider. So spider having 4 arms. So this is 1, 2, 3, 4 arms. This is drum. Lining material. So generally this is asbestos. Or Ferrado material, and this is spring. So in centrifugal clutch, so this engaging above the clutch, so here that is engaging above the engage of clutch. Because of centrifugal force. So this is engaging and this is application. Generally used in internal combustion engine. Internal combustion engine, where that can be start at no load. At no load and engaged before reaching or before or around engaged around 3/4 speed of 3/4 of, you can say this is operating speed. Speed means, or this is at or full speed. Full speed. So this can be engaged. So these are the 4 parts. So this is the lining material. So this lining material touches. This is the internal diameter, means internal surface of the drum. So because of the centrifugal force, and this spring is the tensile spring. So this because of the tensile springs. So that tensile springs that force towards the center of the drum, and because of the centrifugal force, so that is that directions about the centrifugal force, that is towards the diameter of the internal diameter of the drum. So because of that, the engaging of the clutch occurs. So here you can consider, otherwise for understanding purpose, suppose this is brake shoe. So this is lining material, or this is lining brake shoe material. So this may be metal. So lining material, this may be metal. So the this metal may be cast iron, or maybe aluminums, and this is attached with springs. So this is springs. So the springs This force is the spring force, directions of the spring force, and this is PCF. This is centrifugal force. This force is the centrifugal force. So that's why here, please let. Now, and this is the center of gravity of lining shoe. So that's why this is equal to lining shoe. So this is RG and this is RD. Let RD is radius of drum, RG is center of gravity of radius, center of gravity so this is called a radius of center of gravity of brake shoe, lining shoe. M is mass of lining shoe. Z is number of lining shoe. So generally this is 4. This is 4 because this is 1, 2, 3 and this is 4. Next, PCF, this is centrifugal force of shoe. PCF at full speed and PCF1 centrifugal force of shoe during engaging of clutch. Next, number PCF2 omega 1 angular speed during engaging and omega 2 this is angular speed at full speed. Now L is length of lining shoe and theta is angle subtend by shoe. So these are the some of the important terminology above the, or important notations that we use in the, sorry, so because this is to be, and this is spring force. Now so when this brake lining material touches with the brake drum materials and engagement, so after that torque can be transmit during the engagement. Otherwise, and when the speed is decreased, means that is the less than its engagement speeds. So that times disengaging above the clutch automatically. So this is automatically engage above the clutch and automatically disengage above the clutch. So according to the speed variations, if the speed is increasing, engagement starts, and during the running full speeds, that is engaged condition, and during the, when the load demand is decreased and means the speed decrease, so that time means this can be engaged. So this is also can be used in the generators also, so according to the requirement above the speeds. So that's why here, suppose this is brake shoe material, this force which is acting on the brake shoe materials, this is PCF2, and this is spring force. Both are in opposite, because the spring is used, is the tensile spring is used here, and because of this is the frictional force PCF, and this is the frictional force that can be act, and this is forces on shoe. Now the centrifugal forces corresponding to speed omega 1 and omega 2 are given by PCF1 equal to m into omega 1 square into Rg divided by 1000, and PC, this is F1 and this is PC F2. So only change in angular speeds, the rest of the things are same. Now net force acting, because this is why this is 1000 consider due to Rg in mm. Now the net force acting, and here's the centrifugal force at the beginning of engagement is PCF1, and this is equal to and opposite directions to the spring force. So that's why you can consider spring force equal to PS equal to PCF1 equal to M into omega square Rg into 1000. Now net force acting on shoe equal to PCF2 minus PS. So because both are opposite, this is the spring force because of the tensile spring force. So now PS equal to PCF1, or same equations you can write. This is omega 1 squares Rg 1000 or because this is common, so this is W2 and this is W1 and divided by 1000. So this is the net force acting. This is equal to net force. Now frictional force equal to mu into mRg omega 2 divided by 1000. Here frictional force is multiplied by mu. Now, so this is for one shoe. And frictional torque equal to general equations, force multiplied by radius. So that's why force equal to mu into mRg omega 2 squares omega square divided by 1000 multiplied by Rd. So this diameter equal to Rd. So that's why multiplied by Rd. So this becomes Rg Rd omega 2 square omega 1 square and divided by 1000. So this is torque equal to or mt equal to for single shoe, or this is for single shoe. So total torque equal to or mt equal to, here's mu multiplied by z omega 2 square divided by 1000. So by using these relations you can calculate the total torque transmitting capacity of the clutch. So this is the expressions we can use for the calculations above the or for the designing above the centrifugal clutch. Now we will see some of the problems related with the centrifugal clutch. So please note down this. Note down today's first problem. So a centrifugal clutch transmitted a
centrifugal clutch transmitted
20 kilowatt
at 750 rpm
consists of 4 shoes. The clutch is to be engaged at
the clutch is to be engaged at 500 rpm.
So this is N1. The inner radius of the drum is
The inner radius of the drum is
165 mm. The radius of the center of gravity of the shoes
the radius of the center of
gravity
of the shoes is
140 mm when the clutch is engaged.
when the clutch is engaged.
The coefficient of friction is
The coefficient of friction
is 0.3
while the permissible
pressure
on friction lining is
Newton per mm square. Angle subtended by shoe is
angle subtended by shoe is 70 degree.
So please note down this problem.
So important dimensions, yes. This is 520 kilowatt. This is 750 RPM. 165. This is 500 RPM. This is 140. 0.3. This is 70. And this is 0.1. So these are the important dimensions. So suppose this is lining material. So this angle is subtended. This is given 70 degree. This is spring which is rigidly attached here. So this is spring and this is the length. Suppose this is L is length. So this force is PCF2 and opposite force this is PCF1. So first we will calculate this is omega 1 2 pi n1 divided by 60 and omega 2 2 pi n2 divided by 60. So this n1 2 pi 500 divided by 60 equal to 1000 into pi. This is 52.36 radian per second, and this is 2 pi into 750. This multiplied by 78.54 radian per second. Now PCF2 centrifugal force. So this is at full speeds equal to m omega 2 square rg, or directly, otherwise direct. First we will calculate the torque. P equal to 2 pi nt divided by 60 into 10 to the power 6. T equal to 60 into 10 to the power 6 multiplied by P and divided by RPM equal to, that is full RPMs, and this is P equal to 20 kilowatt, right? 60 into 10 to the power 6 multiplied by 20 divided by 2 divided by pi divided by 750. 254647 Newton mm. Now torque equal to, what is formula? Mu into m into mass above the shoes. The mass above the shoes we require while the permission. The centrifugal coil is transmitted at, okay. So what is to be calculate, so that we forget? So please note down, calculate, because here's the mass of the issue is unknown. The mass of each shoe and second bit, the dimensions of friction lining. because we don't know m, and this is multiplied by RGRD into Z omega 2 square omega 1 square divided by 1000. Now we can put value of the this is torque 254,647. Now mu equal to 0.3. This is m. Rg equal to gravity. This is 140. Rd 165. Number of the shoes 4, and this is 78.54 square minus 52 divided by 1000. Multiplied by 1000 divided by 0.3 divided by 140 divided by 165 divided by 4 divided by bracket 78.54 square minus 52.36 square bracket close equal to, so m equal to 2.68. m equal to 2.68 kg. This is equal to, now here's for the second dimensions, the dimension of lining, friction lining. Let B be width of friction lining. So let B is the friction lining. So that's why we knows pressure equal to formula force divided by area, projected area. This is basic formula, projected area. So this is the force equal to, or this is the net force. You can say this is net force. So net force equal to, that is the frictional force. So this is equal to frictional force mu into m into Rg into Z divided by projected area. Projected area equal to, this is L is the length of the, and this is B. L is length of arc of friction lining. So L equal to, so you can calculate L equal to, or theta equal to, so this d theta, length of arc equal to radius multiplied by angle. So radius 140 into angle 70 degree. So this is multiplied by pi divided by 180. So this is L equal to (70 into 70 into pi multiplied by 140 divided by 180, 171.0 mm. Now net force so this is the net force, this is not frictional force, net force, pressure equal to. So that's why, and this is pressure. Now put pressure equal to 0.1, m equal to 2.68, divided by 1000, Rg equal to 140, Z equal to 4, and this is 78.54 square, 52.36, or right, square divided by length equal to 171.04 multiplied by B into 1000. Now B equal to multiplied by 0.1 when divided by answers equal to 2.68 multiplied by 140 multiplied by 4 divided by 1000 multiplied by 78.54 square minus 52.36 square, bracket close, equal to okay. So here's no need about the consider because 4. This is equal to so I mistake here, need mistake, length of the arc. So this should be, this is to be considered, this is RD. I am making mistake here. So this is RD 165. So that's why this dimension change 165 multiplied by 70 into pi divided by 180 201.58. Multiplied by 0.1 multiplied by 1000 divided by answers multiplied by 2.68 multiplied by 140 multiplied by 78.54 bracket square is 52.36 square. So this is equal to near about 64 mm is the face width required. So this is dimensions is required. So next problems. So we'll only see different problems related with the centrifugal clutch. So that's why you should familiar with the centrifugal clutch. So again I will take only one problems related with the centrifugal clutch. So please note down. Second problem, a centrifugal clutch consists of a centrifugal clutch consists of 4 shoes each having a mass of 1.5 kg. So in the previous problems, mass of shoe that is to be calculated. So in this problems, mass of the each shoe is given, and that is 1.5 kg. In the engaged position, the radius to the center of gravity, center of gravity of each shoe is 110 mm, while the inner radius of the drum is 140 mm. The coefficient of the friction is 0.3. The coefficient of the friction is 0.3. The preload in the spring is adjusted in such a that the preload in the spring is adjusted is such that the spring force at the beginning of engagement is 700 Newton. The running speed is running speed is 1440 RPM. Calculate the speed at which the engagement begins. The speed at which the engagement begins the power transmitted by the clutch at, and second, the power transmitted by the clutch at 1440 RPM. So this is simple problem. So first, the speed at which the engagement begins. So this is PCF1 equal to, so this is given 700 equal to RG equal to 110. Omega 1 equal to under root 700 into 1000 divided by 1.5 and divided by 65.13 equal to pi into so this is 2 pi n1 divided by RPM divided by 60. So that's why n1 equal to 60 into 65.13 divided by 2 into pi. $622 RPM. This is your first answer. Second, the power transmitted by the clutch at 1440 RPM. So omega 1 equal to, first we will calculate omega 1, 1 point. So this is 65.13, we already calculate. So next we will calculate omega 2. This is 2 pi n2 divided by 60, 1440. This is equal to 150.8. So what is to be calculate the power? So power means first we'll calculate torque equal to. So torque equal to, what is formula? M into Rg Rd mu m into Z omega 2 squares divided by 1000. Mu equal to coefficient 0.3, 1.5, Rg 110, Rd 140, number of shoes 4, 150.8 square minus 65 point divided by 1000. Mt equal to square minus 65.13 square into 4 into 140, 110, 1.5, 0.3 divided by 1000. So this is 512754 Newton mm, and the power equal to formula 2 pi nt divided by 60 into 10 to the power 6. So that's why 2 pi RPM is 1440 multiplied by this torque multiplied by 1440 into 2 into pi divided by 10 to the power 6 divided by 60. So that's why this is 77.32 kilowatt. This is the power transmitting capacity of this centrifugal clutch. So these are the two varieties of the problems related with the centrifugal clutch. So that's why so this I can declare means this clutch chapters complete. So in the next class we can start the unit 5th, and that is the brakes. So in the brake, two types of the brake. One is internal type of the brake shoe, and another is the external type of the brake. So that we will see in the next class. So that's why today I stop here and we will continue. We can start next chapter is the brakes in the next class. Thank you.